Alright, so today we're going to talk about acid nomenclature. These are the notes. They'll be a little interactive, so if you take these down and take a moment to write all these down, and then I'll be making little notes on this and giving examples along the side. So, here we go. You can either pause the video now and write all of this down, or write it as we go, whichever one will make you feel less rushed. And just so we know, we'll be going in these notes from the chemical name to the chemical formula. So, whenever you see the chemical name, it will be something, 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 acid. The moment it says the word acid, you can write an H. Because acids always start with an H. There are only two exceptions to that we'll talk about. Those two exceptions are H2O, which is water, and H2O2, which is hydrogen peroxide. So those are the two examples. Other than that, acids always start with H. So the first thing you're going to want to do is write the anion. Anion is always the negatively charged ion. It'll either be a nonmetal or a negatively charged polyatomic. So after you've written your H, you'll write the anion. If in viewing the name, trying to get to the formula, the ending of the acid's name is ic and it starts with hydro, then you'll know it's just a regular element, and so it will be a non-metal we'll be dealing with. However, if it does not have hydro in it, then it will be a polyatomic ion. So hydro is your key. You will only have hydro when it is a single element and not a polyatomic ion. So only hydro when it's a single element. If the ending is ic, and there's no hydro, that means that it's with a polyatomic ion, and the polyatomic ion's ending was 8. If the ending of your acid is us, that means it's a polyatomic ion because there's no hydro, and that means that your polyatomic ion ended with ite. So we'll look at acetic acid to start. There's no hydro, so we know it's not just a regular element, it must be a polyatomic, so we move to step 2. The ending is ic. Our ending, sure enough, is ic. If the ending is ic, then it's a polyatomic ion that ends in 8. So, we are looking for the acetate polyatomic ion. So it'll be the acetate polyatomic ion that we'll draw. If in fact, and we'll do several examples on the bottom, or on the next slide. If the ending is us, then it's a polyatomic ion ending in ite. So if you have nitrous acid, sure enough, nitrous ends in OUS. If it ends in OUS, the polyatomic ends in ite. So this is the nitrite polyatomic ion. And you'll need that when you're actually drawing the formula. And last but not least, add a subscript to the H to neutralize the anion. And we'll do several examples of that on the next slide. So here we go. So the three examples we have right now are phosphoric acid, hydrosulfuric acid, and nitrous acid. So phosphoric acid does not have a hydro, so it must be a polyatomic ion. It ends in ic, so you can bet that polyatomic ion is 8. So this must be our phosphate polyatomic ion. Then we have nitrous acid. Nitrous acid was our example before. It must be nitrite. A way you can remember this is a little mnemonic device. If you ate the whole cake, you got sick. So if it's an 8 polyatomic ion, it's an ic acid. But if you take a little bite, it's delicious. If it's an ite polyatomic ion, it's an us acid. So if you ate the whole cake, you get sick. If you take a little bite, it's delicious. Alright, so the next thing we need to do is have those polyatomic ions memorized. If this is phosphoric acid, must come from phosphate. Phosphate is the polyatomic ion PO4, 3 negative. If it's an acid, acids always start with only one thing, an H. But now if you'll recall, H is in group 1, so it just has a positive 1 charge. So one hydrogen is not enough to cancel out the charge of a phosphate. we in fact need 3 hydrogens, because 3 times that positive 1 is the positive 3 we need to cancel out that negative 3. Another trick that works with acid nomenclature, whatever the charge of your negatively charged anion, that will be the subscript on your hydrogen. So that's another trick to remember. Alright, the next one we have hydrosulfic acid. That's technically not correct. It should be hydrosulfuric acid. You're not supposed to say fic. It's a bad word in German. Alright, so because it's hydro, we know it's going to be a single element. The moment we see hydro, we know it's going to be a single element. So what element must we be talking about if we have sulfic acid? The answer, canceling those out. The answer is sulfur. Then the question becomes, what's the charge on sulfur? Well, it looks like sulfur is in group 6, as we call it, because we skipped the transition metals. That means it has 6 valence electrons. It wants 8. If you gain 2 electrons, you become 2 negative. So, because the charge on sulfur is 2 negative, and the charge on hydrogen is just +1, we must need 2 hydrogens. So again, the charge on your anion is the subscript on your hydrogen. 2 times that positive 1 is the positive 2 we need. Those will cancel out, so we cannot worry about charges anymore. Last but not least, we have nitrous acid. If it is nitrous acid, it must have come from nitrite. The polyatomic nitrite is NO2, negative. Every acid starts with an H. Because nitrite has a -1 charge, we will need only 1 hydrogen, because hydrogen has a +1 charge to cancel it out. So we can just erase the charges, and we are finished. Alright, now we're going to go the opposite direction, and we're going to start with the formulas and work backwards to the name. Now, because you've done it one direction, you can just simply try this by inspection. These rules are helpful, but they're really the same rules you've already written down, just in reverse. So we're going to try and just do a few by inspection, knowing what we know. And I'm going to have you try H3N, H2SO4, and HClO. And I'll do the first one with you. It looks like we have a hydrogen bonded to just a single element. Whenever we have a hydrogen bonded to a single element, so remember we're going from chemical formula to name, we always write hydro. When it's a hydrogen bonded to a single element. However many hydrogens does not matter. They're just there to cancel the charge. If it's a single nitrogen, it's hydro. Because it's nitrogen and it's just an element, we've got the prefix hydro, and the ic is at the end. So hydro, nitric, and then acid is at the end of every acid. Hydronitric acid. These next two are polyatomic ions. You'll need to look them up if you don't have them memorized, but remember that if it's an 8 polyatomic ion, it turns into ic acid, and if it's an 8 polyatomic ion, it turns into us acid. So, go ahead and pause the video, attempt those on your own. I'm going to solve them right now. Okay, so the first thing I need to do is identify my polyatomic ion. SO4 to me looks like sulfate, but if I ate the whole cake, I get sick, so it turns into sulfuric acid. Now the rule would lead you to believe that it should be sulfic acid, but fic is a bad word in German, and so we won't be calling it fic. So sulfuric acid, final answer. Because if the polyatomic ion ends in 8, you just change the ending to ic acid. Sulfate turns to sulfuric acid. Last one, ClO. ClO looks like the polyatomic ion hypochlorite to me. So, remember, we are going to write hypo because that is this particular polyatomic ion's name. Do not confuse that with hydro. We are not writing hydro because it is a polyatomic ion. We only write hydro when it's a single element. This polyatomic ion just happens to be named hypochlorite. And so because it's hypochlorite, if you take a little bite, it's delicious. So hypochlorite turns into hypochlorous acid. Final answer. Come in if you have any questions. Good luck studying.